one of its functions as an enzyme. So that protein as a catalyst speeding up reaction. So an example of a catalyst is this enzyme. Okay. Now, with exception of some RNAs, of course, there are some RNAs that catalyze their own self-cleavage. Also, there are enzymes which are RNAs. They are responsible for catalyzing RNA molecules. But the rest are all proteins. So only a few are non-proteins for the enzymes. And the role of this enzyme is to increase the rate of chemical reaction by up to what times? So 10 to the power of 9. So pila na siya? How much? 10 to the power of 9 zeros. Okay, so you have 1, then 9 the zeros. Pila na? 9 the zeros. 1 billion. 9 the zeros. 1. Okay, 1 billion. 1 billion. 9 the zeros. Ang unom, ang tulo, 1,000. Ang unom, 1 million. Ang 9 billion. So, up to a billion times. So, you could imagine a chemical reaction without an enzyme. It's too slow. That's why enzymes or catalysts are necessary for our chemical reaction occurring in our body. Okay? Or it could be up to 20 times. 10 times, 1 times 10 to the power of 20. Okay, so we have some example there of a reaction which is catalyzed by a specific enzyme, urease. So you have there the ammonium or the ammonia plastic carbon dioxide. That is just one example. Okay. Now, what else? Now, others catalyze reactions or other enzymes catalyze reaction of specific types of compounds or bonds. Now, most of the enzymes are very, very specific. Like for example, trypsin. Now, trypsin catalyzes the hydrolases of peptide bonds formed by the carboxyl groups of lysine and arginine. So this dipeptide, say lysine, this one amino acid, and another arginine amino acid bound with a peptide bond. Now, this trypsin will only recognize this dipeptide. Other amino acids bonded with peptide bond will not be recognized by this trypsin. So that is how specific this enzyme is. Okay? So that the same is true with others. So they are stereospecific. Like for example, if we have D-amino acid or D-alanine or say D-lysine and D-arginine, that will not be recognized by a specific amino acid, which recognizes only L amino acid. So sa Fisher projection, ang i-recognize lang ang mga L amino acids. So that is how specific enzymes are. Okay? Now they are commonly named after the reaction or reactions they catalyze. So it's easy to recognize enzymes because they are named according to the reaction they are catalyzing. So we have some examples here: lactate dehydrogenase, acid phosphatase. Okay, now we have these different classifications of enzyme. So these are the 6 major groups of enzymes. So we have the word oxidoreductases. Now, enzymes usually end with ACE. A-S-A. So how do you recognize enzymes? So they usually end with ACE. A-S-A. Now, with this oxidoreductase, so all those enzymes that catalyze the oxidation and reduction fall on this category. Are you with me? Those that catalyze the oxidation or reduction, we say oxidation, what does it mean? What does it mean? Giving up of electrons. How about reduction reaction? Gaining of electrons, meaning the molecule is accepting electrons, that is reduction. And oxidation is giving off of electrons. Now those enzymes that catalyze such reactions belong to this oxidoreductase or oxidoreductases. Now we have another transferases. So we have the word transfer. So when there is when one molecule needs to be transferred to another molecule, so has to be shifted to another molecule, then there is an enzyme called transferase or transferases that would catalyze such reaction. Hydrolases. So you have the word hydrolysis. Lysis, splitting. Hydro, water. There is splitting of water. So the enzyme that catalyzes such splitting of water is classified under hydrolases. Lyases. Lyases is addition of groups to a double bond or removal of groups to create a double bond. Especially, say when there is a need of adding or removal of a bond to make a double bond or a single bond. So that is lyases. The molecule that catalyzes such is classified under lyases. Then we have isomerization. We say isomerization, iana lang nimo. Say, if this is not the structure, ibalini mo ana, that is isomerization. Okay? So, the enzyme that participates in that reaction are classified under isomerases. Okay, just like for example, I'll give you one example of isomerization from glucose to fructose. Ano na siya, fructose na, or galactose. Bali lang ang hydroxide ion sa fourth carbon, bali lang sa nahimo ng galactose. So that is isomerization. Now, ligases, you have the word ligate. Have you heard that?
Yes.
Ligated. Akong mother is ligated. You usually heard this. Ligation. So you have the word ligate means joining as to what has been cut off. So when you join the two molecules together, that is ligation. Okay? So joining of two molecules together. The enzyme that participates in the joining is called ligase. Okay, so we have some specific example for oxidoreductase. Like for example, pyruvate. What is pyruvate? Are you familiar with pyruvate? Anybody? Pyruvate? Now pyruvate is an intermediate, or say that's the end product of glycolysis. And glycolysis is the process of breaking of carbohydrates to produce pyruvate molecule. It's a 3-carbon compound. Okay? So, when pyruvate is acted upon by this lactate dehydrogenase, so it produces now lactate or lactic acid. So, this is during lactic acid fermentation. This is anaerobic respiration. Especially when you indulge in strenuous activities, mountain climbing, saka-saka, then kapoy na kayo imong muscle. Now, because your muscle goes for, aside from aerobic, you also indulge your muscles get tired and it need more of this anaerobic cellular respiration. So the pyruvate, especially when you run out of oxygen and then you indulge in strenuous activity, especially mountain climbing.
So pyruvate end product.
End product of breakdown of glucose in glycolysis. So that will give you the lactate or the lactic acid. And the accumulation of this lactic acid in your muscles that creates now the pamaol or muscle pain. Are you with me? So, have you experienced pamaol or muscle pain? Yes. Okay, that is due to the conversion of pyruvate to lactic acid. So, it's acted upon by lactate dehydrogenase, which is one of the oxidoreductases. Huh? Kana. So, grabe na-strain na yung muscle and then na-accumulate more of this lactic acid. So, munang nalagay pamaol. Okay. Now, anyway, that reaction is reversible. That is reversible. So later on, when oxygen supply is already abundant, then the lactate or the lactic acid will be converted back into pyruvate. And then pyruvate will enter the Krebs cycle for citric acid cycle. Okay. Now another, we have transferase. So you have aspartate plus the alpha ketoglutarate will give you oxalosuccinate and glutamate. Now you have here the enzyme aspartate aminotransferase. Now alpha ketoglutarate, aspartate or aspartic acid is just the same, no? Pero this is when it gives off its hydrogen atom. So when it gives off its hydrogen ion, then the aspartic acid will become aspartate. Then you have the alpha ketoglutarate. Alpha ketoglutarate is one of the intermediate products in citric acid cycle or Krebs cycle. So it would be transformed into another form, oxalosuccinate and glutamate by aspartate aminotransferase. Now another, we have hydrolase. Hydrolase, say example, we have acetylcholine. Acetylcholine is one of the neurotransmitters. One of the neurotransmitters